Hello all. Today we will discuss about the cooling load calculations process. So while we do the designing for HVAC, we know the cooling load, and by that information we design our HVAC system in buildings, like what will be the size of duct, what will be the size of uh, systems, fans, and which type of air conditioning we are going to give to our buildings. So for that we have to take some points into consideration. So these are some uh, terms and points which as an architect and we should know while we do the designing process. And uh, as building is a process which start from the designing stage to the construction, and after that operation and maintenance also becomes the part of buildings and the liability and uh, responsibility of architect and engineers. So the calculations process should calculate these terms like external and internal design condition. What are the external and internal design conditions for that site and that particular building? External, like what is the latitude, altitude, and how the orientations we have given the building, and how much radiation we receive at that point and on that building. And internal design conditions, about what is the level of thermal comfort and how the temperature difference inside and outside, and the all other component of uh, uh, design aspect into a building. Then area of each facade and area of glazing. So area of each facade and area of glazing is calculated while we do the calculations uh, for the cooling load and calculate the heat gain. And so we determine some specific area for glazing, and we give the certain amount of exposure to the building, to the most sun receiving part. So we should uh, do it in our design process that no longer facade should be to expose the sun, so that will add the heat load and cooling load to the building. So like heat gain through roof and wall, radiation, re-radiation. So radiation, direct heat coming to the surface, re-radiation after the sunlight uh, radiated by the any object outside the building, that also cause the heat to the building. So we should take all these considerations while we calculate and while we design the building. Then comes heat gain and temperature difference. So we gain heat in building through temperature difference. So our window receives the sun amount and radiation and heat through temperature difference outside to inside. So this temperature difference is also considered while we do the load calculation process. Then comes internal load and external load. So internal load, all the occupancy in building, all the machinery and which radiate heats, and the this internal load is uh, sometimes latent by the object. And external load, how much the radiation we are receiving and how much the direct sun and direct uh, heat is coming to the building. Then total load we estimate by this formula like sensible plus latent heat. So sensible heat, which is we sensed directly, or which is a heat gain through direct heat gain from outside, plus latent, and latent is through peoples, through objects, and uh, which heat is in form of uh, So we calculate this as a uh, data from outside temperature, inside temperature, and we get our sensible plus latent heat. Then we consider transmission coefficient value or U value of material, like U value of wall, U value of uh, window. Then resistivity of material, which type of construction is that, which type of material we are using in building, that have some resistivity. And by resistivity we get the R value or resistance, and R value is resistance of that material resisting the heat transfer through its particle. So U value here is uh, 1 by R. So thermal conductance is inversely proportional to resistance. So if resistance is greater, then U value or thermal conductance will be lesser. So it depends on the resistance of the material and of that particular wall or particular feature of building. So overall cooling load calculation process has these points which we have discussed, and the applications for design aspect and for architect is we should prepare our design for minimizing the energy load for the building in a effective manner by considering all these parameters like area of facades and area of glazing. We should follow some rules, some specific proportions, specific orientation to avoid the maximum load which is needed in building by faulty calculations. So sometimes the building gives ill building syndrome characteristics if the cooling load process is not good and the building attracts more heat in summer, and the HVAC system is also not efficient in terms of cost and in terms of maintenance. So we learn about the heat, temperature difference, and different type of heats like latent heat, sensible heat, then it becomes total load, and area of facade, and depending on U value and R value. So we calculate the load calculation process, and it is calculated at a peak load time. So whenever the peak load in building, that time only we calculate all the related load like inside, outside, and uh, external, internal, and all the load by occupancy and by the machinery and heat loss as well. Then we get the actual cooling load. Okay, and it varies sometimes to the climatic zones. Then we are able to give this cooling load process to our design. Thank you.